All right, we're going to do vectors in space, which means a lot of the same stuff is going to happen, except for we're going to add a third component. So looking at our traditional XY coordinate plane, we would have X here and we would have Y here. But there is an axis, look at my pen, that comes straight to you and it goes down through, and that allows you to plot three-dimensional objects. So for instance, if I want to plot this calculator, which would be kind of sort of like a rectangular prism, I could have length and I could have height, and then I could also have depth because I can measure the depth of this thing. So we're going to modify how we look at this. So we're no longer going to have an XY coordinate plane, and we're no longer just going to be restricted to I's and J's. Guess what's next? K's. All right, so what we're going to do is look at a three-dimensional like this. And it's kind of weird to see. Pretend like you're looking into the corner of a room, and that's the origin. And so this is the axis between the floor and the wall. And then this is between the floor and the wall. And then this is between the two walls. So you're looking at the corner of a room from inside the room. So this is going to be your positive x-axis. So from here, you're going to come this way to go positive. Well, you can also go that way to go negative. It's just harder to see it that way. This is going to be your y-axis, and so it's this way to go positive, and then it's this way to go negative, but again, it's harder to see it that way. And then this is going to be your z-axis. So z is going to go up, and then it can go down. And so imagine then that you're in quadrant 1, and you're looking down into the room. So you're up here, but you're in space, okay? And you're looking to the corner of that room. So I'm hovering in quadrant 1, looking at the origin. And then so we just kind of sort of look at it from this perspective, and then we can twist things and stuff later. Now, what you also need to realize is that I used to have quadrants. Well, now I still have a positive xy, a negative x, positive y, negative x, negative y, and then positive x, negative y. But now I have a positive z and a negative z, okay? So I've got this positive space up here. So I've got all of the positive z's. And then on this side of the paper, okay, underneath the paper, I've got all the negative z's. So instead of having quadrants, which is 4, we have octants, which is 8. Okay, so the way that I plot this, now let's go back for a second before I plot that. Recognize that this is in 2 dimensions. So we have 2 dimensions. Okay, so we've got length and width. And if I give you something like x equals 3, I'm referring to 1 dimension. Okay, so x equals 3 refers to something with length, or something with width, or something with height, but not any combination of the above. So that would drop down a dimension, and it would be a vertical line that slices through the x-axis at 3. So if I'm plotting points, and if I want to plot all, so remember this is all the x values, and y's can vary. So let's do something else, and let's say that y is going to be 2, but this time we are in space, so I've got x, y, and z coordinates. And so what that means is that all the values where y is 2, so it's going to go this way, and it'll come up this way, and this way, and this way. And so what you have is a plane, so it's 2 dimensions, length and width, where all of your y coordinates are 2. And it is parallel to the xz plane. Okay, so think about just a sheet of paper slicing through the x and z axis. And then the plane y equals 2 is going to be parallel to that. So hopefully that gives you a little bit of insight on what we're looking at. And then again, we're going to have A on I plus B on J, and then we'll have C on K. That looks like an E. We'll have C on K. So we're going to add a K coordinate to this. In that respect, everything else is the same. So I find my position vectors by subtracting my x's, my y's, and my z's, terminal minus initial. I can find dot products, okay? I can find, what else can I find? I can find magnitude, okay? So all of these things are just extensions of what we have here, okay? It's just going to be in 3D instead of 2D. And so if I want to find a formula for an algebraic position vector, I'm also going to have z2 minus z1. And that's going to give me this. I'm going to have ai plus bj plus ck. Okay. I can find magnitude simply by taking the square root of a squared plus b squared plus c squared. Okay. Unit vectors are going to be found the same way. You're going to take each component divided by the magnitude of the vector. So all these things are the same. This is not quite the same because it's different. So what we have when you look down here is I've got direction cosines and direction angles. So I'm going to find these things by looking at the ratio. And so I'm going to put this thing in a unit vector form, and then I'm going to take the cosine of each ratio, and which will tell me the angle measure that it occurs at. So I'm going to take the arc cosine, sorry. But notice I've got an alpha, a beta, and this is gamma. It looks like a fancy Y, but it's not. It's in Greek alphabet. It's like ABC, but it's alpha, beta, gamma. Okay. And then this is what we had in the last lesson. So basically, I'm going to let you do a vast majority of this section because it's the same. It's just in 3 dimensions. And you can always email me if you're stuck. But I would like to practice just a little bit and find a dot product and an angle between two things. Okay, so if I've got a dot product, so my vector v is going to be in 3 dimensions. So I've got a negative 2i plus 3j plus k, and then I've got vector w, and that is going to be 4i, so 4, 1, 3. So 4, 1, and 3. And first thing I want to do is find the dot product and then use that dot product to find the angle between the two vectors. So notice that this is going to be a little bit different because we morph it into this. Okay, but I can still find the angle between two vectors because I know how to do a dot product and I know how to do their magnitudes. It's just that the magnitude is going to have 3 components instead of 2. Magnitude is going to have 3 components instead of 2. So I am going to use, once again, this formula. So the cosine of theta is going to be the dot product between the two vectors divided by the product of their magnitudes. So looking at that, my dot product is going to be negative 2 times 4 is negative 8. 3 times 1 is 3. And 1 times 3 is 3. So negative 8 plus 6 is negative 2. So I've got the cosine of theta is negative 2 over. And then I need to do the magnitude of v. So the magnitude of v is going to be negative 2 squared, 3 squared, and 1 squared. And then the magnitude of w is going to be 4 squared plus 1 squared plus 3 squared. So that gives me 4 plus 9 plus 1 is going to be the square root of 14. And 16 plus 1 is 17 plus 9 is 26. So I get the square root of 14 times the square root of 26. So looking at that, if you want to do this, we've got 14 times 26 is 364. So I've got the square root of 364. And now I can find the angle between these things by taking the arc cosine of both sides. So the arc cosine of negative 2 root 364. Make sure you're in degrees. Am I in degrees? Yes, I am. So the arc cosine of negative 2 root, 364. And I get 96.01 or 96.02 degrees. So my theta is 96.02 0.02 degrees. Okay, so the last thing that we're going to look at in this section, because it's new, is going to be your direction angles and your direction cosines. Okay, so for instance, if I have a vector in rectangular form, and it's a negative 12i plus a 4j, and then minus a 6k. I want to rewrite this using direction cosines, direction angles, and that's going to put it in a polar form is what it will do. So the first thing I need to do is find out what my magnitudes are. And so I'm going to change this into a unit vector. Okay, so my magnitude on V, and I'll explain in a second what you just did, gives me 144, because negative 12 times negative 12, plus 16, plus 36. So if I've got 144 plus 16 plus 36, I get 196, and the square root of 196 is 14. Okay, so now coming back up here, I'm going to change this into a unit vector. So my unit vector is going to be negative 12 over 14 on I, and it's going to be 4 over 14 on J. And yes, you can reduce these, and negative 6 over 14 on K. So if I want to find the direction angles, the way that we're going to do this is it's easier to find and measure the cosine of each component. How does that component relate back to the origin into the axis? Okay, so that's what you're finding is if you look at just this, so remember this is a ratio. So if I've got a negative 12 over 14, if I complete that ratio, then what angle does that make with the axis or from the origin? From the origin is what I should say, because your axes are going to change depending on what octant you're in. So for alpha, I can find, and then we're going to rewrite this whole thing from start to finish. I want to find the cosine of alpha, which is this one, is going to be a negative 12 over 14. So alpha must be the arc cosine of negative 12, 14. So my alpha is going to be negative 12 over 14, and I get 149 is what I get. So 149.0 degrees. So let's squish this in here, different color pen. So I've got the cosine of beta is going to be 4/14. So we're going to do beta equals the arc cosine of 4/14. And again, I didn't reduce it just because I didn't need to. If you were going to return this as a unit vector, you would reduce this to a negative 6/7 and a 2/7 and a negative 3/7. But we're not doing that. So beta is going to be the arc cosine of 4/14. So 4/14, which means the angle for your J component is at 73.4. So I have 73.4 degrees. And then for gamma, we have the cosine. Someday I'm going to learn to write further left. So the cosine of gamma, which looks kind of like a weird J, is going to be negative 6/14. So that means my gamma is going to be the arc cosine of negative 6/14. That says negative 6. Okay, so gamma is going to be the arc cosine of negative 6/14, which gives me 115.4. So my gamma is 115.4 degrees. All right, so how do I rewrite this whole thing? Remember that just like we did in polar, I am not going to turn, I'm going to leave this in terms of cosine. So my vector is going to take this form right here, which, holy cow, I need to fix that. My vector is going to have, this is a typo, for the love. Okay, my vector is going to be the magnitude of this times all that mess right there. Okay. So what I end up with is going to be, I have, my magnitude, that irritates me, is 14. And that's going, so that's your radius, okay? And then I'm going to have the cosine of alpha, which is 149 on I, plus the cosine of beta, so the cosine of 73.4 on J, plus the cosine of 115.4 on K. So remember, don't find that ratio, because if you find the ratio, you'll be right back here in rectangular coordinates. So don't do that. All right, and so that is how you're going to find that. And then literally, that's pretty much it. That is pretty much it. So I will see you in the next section.